plus. And this is 2, 8 as the arrangement because it has lost 2 electrons. 2 positive because 2 electrons have been lost. This is a fluoride ion, F negative, and these are 2, 8. And there are 2 of them. 2 fluoride ions. And you can say that the compound formed is magnesium fluoride, which is MgF2, because we have 2 fluoride ions combining with 1 magnesium ion. So the formula is MgF2. We used 2 fluorine atoms because magnesium is losing 2, but fluorine can only gain 1. So we can also have another one of formation of magnesium oxide. And this one we can directly go to the diagram. So magnesium and oxygen. 12P, 12N. So that is magnesium. (282) plus oxygen. Oxygen is 8P8N. We use the dots here. So the arrangement is 2, 6 because the total number of electrons. So oxygen is 2, 6. So we say that oxygen atom arrangement is O, 2, 6. So in this case, we are saying that magnesium is losing 2 electrons and oxygen is gaining 2 electrons to attain a stable arrangement. So the 2 electrons lost by magnesium will be gained by oxygen. So the diagram after that result that diagram will not fit here. Let's just is a continuation. Let's have it here. The product. So we'll have 12P, 12N for magnesium. So these will be 1, 2. We usually put the electrons in pairs unless it is 1. So that is 2, 8 magnesium after losing 2 electrons. So after losing 2, it acquires 2 positive charge. Then we have oxygen. Oxygen was 8P8N. The arrangement was 2, 6. Now it is 2, 8 because it has gained some 2 electrons here from magnesium. So by gaining, it acquires a charge that is 2 negative. So this is a magnesium ion, Mg, 2 positive. The arrangement is 2,8. Oxygen forms an oxide ion. So O2 minus, like that. And the whole of this compound is what now we are referring to as magnesium oxide, because it has a magnesium ion and an oxide ion. So there's something that is important to note here, that for nonmetals, when they form their respective ions, their name changes a bit, and we add an IDE at the end. So for oxygen, we have oxide. For chlorine, we have chloride. For fluorine, we have fluoride. So, but for the metals, the name just remains. Magnesium remains, calcium remains, sodium remains. But for the ions of nonmetals, these are the ones that we add an IDE at the end. So hence oxide, not oxygen ion, but oxide ion. Not fluorine ion, but fluoride ion. So the assignment, the first question, using a dot and cross, dot and cross diagram like the ones we are drawing, show bonding in potassium oxide, calcium chloride. Number 2, name the ion formed by phosphorus and hydrogen. So we are going to stop there until the next time. Goodbye.
Welcome to Manifested Publishers.
Hello learners, welcome to this lesson. It is Chemistry Form 2 and the topic is Chemical Families and Patterns in Properties. If you remember, in the previous lesson we discussed the chemical families and we discussed a brief about the alkali metals. We said they are also called group 1 elements, and we also wrote the electron arrangement of the first 3 group 1 elements. Lithium was the first element. We said the configuration is 2, 1 because it has 3 electrons. The second was sodium. The configuration was 2, 8, 1. And the third was potassium. And the configuration was 2, 8, 8, 1. Since that the reason why they are called group 1 elements is because they are having 1 electron in the outermost energy level. And the 1 electron enables them to be placed in group 1. If you look at those 3 elements, that the sizes are different, that lithium is the smallest and potassium is the largest, depending on the number of energy levels which are present. That lithium has 2 energy levels occupied by electrons, sodium has 3 energy levels occupied by electrons, and potassium is the largest with 4 energy levels which are occupied by the electrons. And therefore, that's why we are saying that the size of potassium is larger than the size of sodium, and the size of sodium is larger than the size of lithium, depending on the number of energy levels which are occupied by electrons in each atom or in each element. In this lesson, I want us to discuss the gradation in size of atom and ion. Gradation in size of atom and ion. Remember, this is gradation in size of atom and ion of alkali metals. So gradation just means there's a systematic progression. A systematic progression on the size of atom and ions in group 1 elements. And I will explain this using a table which I'm going to draw for you so that we discuss it from there. This table is having the element. Therefore, that is the table. I want us to look at the gradation in size of the atom and the ion of alkali metals. These are the alkali metals. So the alkali metals are lithium, sodium, and potassium. Then their symbols, the letters are not supposed to be touching one another. So we have lithium, sodium, and potassium. Those are the symbols. The atomic number, lithium has atomic number 3, sodium has atomic number 11, and potassium has atomic number 19. Then writing the electron arrangement, these ones we have already written or we discussed that in the previous lesson. So lithium has configuration of 2,1, sodium 2,8,1, then potassium 2,8,8,1. Then we look at the atomic radius, that the sizes of the atom and the ion, these ones are too small, and hence you cannot be able to measure them in the laboratory because their sizes are too small. You can see the units of measurements, they are nanometers. Nanometers are very small units. You cannot be able to measure them. It's too difficult because their sizes are too small. The sizes of the atoms of these metals or these elements are too small. So you cannot be able to measure them unless under special places. So the atomic radius are measured in nanometers. If you look at the atomic radius, lithium, atomic radius 0.133. That is the atomic radius of lithium. Then sodium, the atomic radius is 0.157. Potassium, the atomic radius is 0.203. The ionic radius for lithium is 0.060. Then for sodium, the atomic radius is 0.095. And for potassium, the atomic radius, not atomic but ionic radius is 0.133. If you look at the atomic size and the ionic radius sizes, then both are increasing down the group. So we can say that atomic radius, we need first of all to define what atomic radius is. This is the distance from So atomic radius refers to the distance from the center of the nucleus of an atom to the outermost energy level occupied by the electron or electrons. For example, if this is an atom, this is an atom, this is the energy level, This is the nucleus of that atom. Let's say atom is lithium. So the lithium atom, this is the first energy level. The first energy level has 2 electrons, and the outermost energy level has 1 electron, because the configuration of lithium is 2-1. So 2 electrons in the first energy level and 1 electron in the outermost energy level. Therefore, the atomic radius is now the distance from the center of this nucleus to the outermost energy level. So the distance from here to here, that is what we are calling the atomic radius. So refers to the distance from the center of the nucleus of an atom to the outermost energy level occupied by an electron or electrons. So this is an atom of lithium. An atom of lithium looks like that. Then when you talk about the ionic radius, we are referring to the radius of these elements having undergone ionization or having formed ions. And these elements, they form ions by losing 1 electron in the outermost energy level. Group 1 elements group 1 elements form ions by losing 1 electron in the outermost energy level. Therefore, if they lose electrons, or they form ions by losing electrons in the outermost energy level, they become ions. And when
Welcome to Manifested Publishers.
Hello and welcome to the Manifested e-learning forum. The subject is business studies. We are on the topic